It's a lot of personal information there.
I'll tap got it again because it's popped up on my screen again.
Yeah, so just click on got it.
Okay.
And we are now streaming live to YouTube.
Okay.
So Ed, do you know how to stop screen sharing?
I thought I clicked on stop screen.
No, we're still seeing your screen. So if you're on a laptop or a computer up at the top, you'll see that you're viewing the screen, and then it will give you some options, and you need to stop screen sharing.
It's Mac. It doesn't tell me anything. I don't see it on my.
Right at the top.
Right at the top, there'll be a little box right at the top that will say that you're screen sharing right at the very top of your screen. It might be green.
Oh yeah, I see it. Stop share. Mind your own.
There we go.
Oh, yeah.
Okay. All right, Bernie, we're ready to go.
Okay, I'm done. See ya. Good night, everybody.
Right, green. Green.
Oh, welcome, everybody. Boys and girls, men, ladies and gentlemen, dogs and cats, and other sundry critters. We have a whole lot of information to get to you tonight. Hopefully you'll gain some inspiration from it. We're going to run through a bunch of announcements. We have our speaker, of course. We're going to have a bit of a break. Then, of course, the draws. You can't forget the draws. And then we'll have Steve, or sorry, yes, we'll have Steve at one point, and then we will have Matthew at the end of our meeting. Now, I haven't done this in so long, I almost forget how to do it. But we'll start off with a few announcements. The calendars are pretty much ready. We will have Doug Turner give us a little insight on what's on the calendars and so on and so forth. And in fact, why don't we do that now? Doug, where are you? Doug?
I'm here, Bernie.
Oh, there you are.
Hang on, I gotta turn my camera on.
Oh,
There, oh. There we go.
there he is.
So, you want me to talk about the calendar now?
Might as well do her now.
Okay. Well, I have a prop. See, it says 2022 at the bottom, and there are actually pictures and stuff on the inside. But it's really hard to see this way. So what I'm going to do is start sharing my screen, because I actually have, I'm semi-prepared, I have a PowerPoint for this. So this, someone will tell me if you can't see it. This is the Celestial Events Calendar for 2022. First thing I'd like to do is say thank you. And this goes out to a lot of people. First, everyone who kindly contributed their images to the calendar. It's really honestly, without your photographs and without your help, we end up with a calendar that has a bunch of white pages in it, because I couldn't make anything else up. I'd also like to say thank you to all of the club members who helped putting the data together for the calendar. So the things like the observing dates and the holidays and moon phases and all that kind of stuff, that all has to be gathered and put together before the calendar is actually assembled. I'd like to say thank you to, there's an echo here. I'd like to say thank you to all of the members of the image selection committee. They've had a very difficult job this year. They ended up picking 18 images out of a group of 65 outstanding, spectacular photographs. They did an amazing job, and you will see that in a few moments. And I'd also like to say thank you to all of the club members, that's you guys out there right now, who are considering purchasing one of these calendars, because you will help support the club, and you'll actually get something that's kind of useful. Now, before you actually purchase a calendar, I need to say a word about what you're going to see tonight. The images that are going to show on your screen will definitely be different than the ones that you will see in the calendar. There's a whole bunch of technical reasons for this, but what it boils down to is that every single one of us is looking at these images on a different screen, and all those screens are calibrated differently, and a whole bunch of reasons for it, but the calendar will be really close. I've worked hard at making sure that the images that were sent to me by the submitters are as close to what they sent when they're on the printed page as we can get. That being said, let's have a look at some images. This is the first one that you will see. The reason for that is because it is on the first page. It is the cover image, and this was submitted by John Govero. It is called Stars Over a Moonlit Landscape, and I believe John said it was at Gull Lake, but I'm not 100% positive because I don't have that written down in my notes. The next image, this came from Stephen Lee. Now, these aren't exactly in order. This image will appear on the gallery page in the back. Now, this image is from Stephen Lee, and it looks a little weird on my screen, but it actually turned out really well on the calendar. And it's Comet Neowise, in case you didn't recognize it, and the location is at Binbrook, and that was taken one night when we were having an observing night. This is January's image. It's by Michelle Odette. And again, I haven't said this yet. If I do butcher your name, my apologies in advance. I'm horrible at translating phonics, letters and stuff like that into actual sounds, which is odd because Sue teaches people how to do that. She hasn't taught me properly yet anyway. Anyway, this is NGC 7635. Fabulous image from Michelle. Michelle, and it's in January. The next image that we have is Jupiter and Europa by Adam Jaworski. This will be your February picture. So you can actually have these pictures up on your wall for an extended period of time, up to 30 odd days if you like. Next we have M27, Adam Kepik, or anyway, I'm just going to leave it at my first attempt. This image will be shown on for March, so that's an amazing photograph. We next have Bernard's 33. I think some of you may know this is the Horsehead Nebula, and this image will show on your wall for about a month, but that will be the month of April. And this is from Mike Hamilton. I think Mike's done an outstanding job with this image, as all of our photographers have done. Joanne Salchi took this picture of a solar pillar out of her, I think it was out of her window in her backyard. So you can see it in the center of the screen. It's a little bright on my screen, so it might not actually show up as well here as it does in the calendar. But this is an example of something that you can see a celestial event in the daytime at home. And you don't have to have a powerful telescope to see it. And this next one is a similar example. This comes, Joanne's solar pillar image is in one of the gallery pages. This image is Bob Christmas's solar eclipse, and you'll see this image in May. I believe Bob took this down at the lakeshore in Hamilton or Burlington. I can't remember exactly, and it's not in my notes like many others.
Burlington Pier.
Burlington Pier. Thank you, Mike. Thank you, Bob. From Peter Woolsey. It is NGC 6946. I think it's also known as the Fireworks Galaxy. And this will be in your calendar for the month of June. July comes to us by Matthew. And this is M92. Now, those of you who spend a lot of time looking at Hercules, you probably spend some time looking at M13. This is another object that's in Hercules. It's almost as brilliant and as bright as M13, but you can find this one in July as well if you can't find it in the sky. It's on your wall in the calendar for the month of July. The next image, this is Caldwell 4 by Janice Mannering, and it shows up in August. Again, this is another image that will look much better on the calendar because the way displays work, the blacks don't come out the way they should. But anyway, this image will be much nicer on the calendar. But Janice did an amazing job taking this in the reflection nebula because of the color. I got that. And you can see this image in August. The next image, this is from John Govro. It is the first quarter moon. And for those of you who did not recognize this object, I believe the club is going to be holding an Astronomy 101 clinic again, so you might want to consider signing up for that one. But someone who won't have to sign up for that will be Bill Takash, who gave us this image. This is called the Ghost Nebula, also known as IC63. Now, this image will be in your calendar for October because it's the Ghost Nebula. Now, the next image that we see is called Catching the Sun 2. This was taken by Dan Copeland. It will be in your calendar for November, and Dan spent a considerable amount of time getting himself into the right spot so that the sun was just touching the top of the tower that's on the Burlington Pier. So, like many of these other images, some planning and effort went into making this image. Now, this planning and effort one, Dan Copeland's image will be for November, if I didn't mention it. This image took a little bit of planning and being in the right place at the right time, just like the last one. This is Venus and the Moon, taken by Bob Christmas, and it will be in one of the gallery pages. Now, this is an interesting version of the moon. This is called Astral New Moon. This is by Lorraine Schneier. I'm sorry about the name. Anyway, Lorraine, if you're here, please correct me. This is one of the gallery pages.
Hi, Doug. It's Snyer.
Snyer, thank you very much. I would never have ever figured that out from reading the letters. Okay, Snyer, thank you very much for submitting this image. This is a painting that Lorraine did, and it has been sold into a private collection. I imagine there was a tremendous amount of work that went into this. As much work as went into some of the images that you've seen already by astrophotographers, but maybe with a little bit less gear and maybe a little bit less expense. The next image is December. This is from Michelle Odette again, and this is NGC 6946. Yeah, again, this is the Fireworks Galaxy, and then we've got two examples of this year because they were both really, really well done. On the back cover, you will see Saturn. This is by Adam Jaworski again. A lot of time and effort, and this image comes from a set of video frames. So if you're thinking that you need to have a fancy camera, well, you might have to have a fancy camera, but if you're thinking you need to have a fancy camera, you might want to consider doing planetary images with video because you take lots and lots of images. The last thing you might want to ask yourself is why not buy one of the HAA's 2022 celestial calendars? They make great, there's a couple of reasons why you might want to. I can't think of any reason why you would not want to. So the reasons for buying them end up that they make great Christmas presents. Who doesn't want a real physical paper calendar that they can hold in their hand and hang on the wall? They're really, really cheap. They're very inexpensive. They're not cheap. We actually print them on some really high quality paper. You can get even more details about the images because in our calendar, we list some of the equipment that was used and time, exposure, things like that. So if you're interested in finding more about how some of the images were done, you have to buy the calendar because I'm not going to tell you. Another thing that you'll find is that there's a whole bunch of observing things to find. There's at least one a week. And everything that's listed in the calendar so that for you to find is actually something that you can find from Hamilton. So we spent a lot of time making sure that the stuff was at least visible at some point in time. Some of them are really easy, but some of them are very, very challenging. So if you're looking for something additional to do, this is one place of getting a bit of inspiration. There are also some what I will call informational tidbits in the calendar. You just might learn something from here. For example, one of the tidbits that's on this year's calendar is that Galileo discovered dactyl in 1993. Now, think about that for a minute. See if you can figure out what it means. And if you can't, are you curious enough to try? Did I mention that the calendars make really great gifts? So anyway, I will let someone from the council give you a little bit more information about how and where and when to get them, but they will be available fairly soon. And that's it from me. So I'm going to stop sharing my screen. Back to you, Bernie. I'm done.
So thank you very, very much, Doug. And thank you to all our contributors. Calendars will be selling at $10 a piece. If you want it mailed to you, the price becomes $15. Ordering will be through, I believe it's supposed to be on the site. How did we decide on that? And? No, okay.
Sorry, I'm
Well-
here. Yeah, it is going to go up on the website as soon as we can, as soon as the calendars are actually available and we can start taking orders.
Okay, good. All right. So let's move on to our guest speaker, Mr. Simon Poole. Where are you, Simon? I know you're here somewhere. I see a whole bunch of names. There he is. There he is. Welcome, Simon. You and I have not had opportunity to speak to each other as yet. Glad you could join us.
Oh, thank you for having me.
Simon is a vice president of the RASC, a vice president.
I'm the president of the Calgary Center of the RASC here in Calgary.
Okay. I had it that you were a vice president of the RASC and the president of the Calgary chapter.
Mm-hmm.
Okay, good. And you hold a Master of Science in Physics and Astronomy.
That's right.
You will be speaking to us on the voyages of Nicholas de Lacaille. And I will leave it to you to explain who he is and what he did and why he is important to us.
For sure. Yeah. Let me get my screen sharing going. Make sure it's working okay.
There we go.
All right. Do you see my note screen or my presentation?
Simon, we can
See both.
see the presentation as well as your notes.
Okay, there, I'll just switch it over. That should be better.
That's just the presentation now.
Perfect. No, thanks again for having me tonight. As I mentioned, I'm the president of the Calgary Center of the RASC, and I've been doing that for about a year now. And I have another year term starting actually this upcoming Thursday. So pretty excited about that. And something that I studied a while ago was I read a book on Nicolas Louis de Lacaille. Now you'll have to forgive me for my French pronunciations. I'm not very good at those. Being so far out west, so far from the influence of Quebec, I may mess up some of the names. So I apologize if I do that. But no, I read a book about Nicolas Louis de Lacaille. I'll just call him Lacaille from now on. And his contribution to astronomy about 300 years ago. And, you know, a lot of the time when we think of French astronomers, we think Charles Messier and people like him. And Lacaille, he's not very well known compared to Messier. Messier has his whole catalog named after him, and you know, I'm sure many of us have looked at Messier objects maybe just within the past week, so he's always at the forefront of our mind. But I want to talk about Lacaille and his contribution to astronomy, because it is quite vast, maybe as vast as the universe, but who knows. So just to kind of go through this talk, I entitled this talk "The Southern Hemisphere Laboratory," and you'll see why as we go through this talk. I just want to, we'll start off with his early life, his work in the Southern Hemisphere, the instruments that he used, and then get into his later life and the people that he influenced along the way. Then we'll get into the really fun part. We'll talk about the constellations and Lacaille objects in in the catalog. So his early life, he was born in Rumigny in Ardennes on March 15th, 1713. Now this is about 15 years before the birth of Charles Messier, just to kind of give you kind of a relative scale of those two astronomers. And yeah, he was born in north of France, and his grandfather had been a clerk of the court of Rumigny, and his father was a gentleman of the Royal Guard. He was an artillery officer and acquired some knowledge of mathematics that he passed on to his son. He became known to Louis Henry, the Duke of Bourbon, and a prince and who was also the prince and prime minister from 1723 to 1726. Now, while Louis XV was the king. He and his wife, they had 6 daughters and 3 sons. 3 of the daughters became nuns, and all the other children, except Nicholas Louis, they died young. So he had quite a large family, but only a few of them survived into adulthood. Now, Delicai, he was homeschooled and was sent to several colleges. He studied rhetoric and philosophy, big fields at the time. And during his studies, he uncovered the geometry of Euclid, and that kind of piqued his mathematical interest. But he was kind of told to study theology. Each day he would study theology, and then at night he would immerse himself in mathematics and astronomy. And an interesting anecdote is that during his final examination, the under-chancellor of Notre Dame, the official was angry at Delicai for his Enlightenment philosophy, and he intended to not give him his degree. But he was eventually convinced under protest to grant the degree when colleagues testified as to the merits of Delicai. However, this incident, it kind of soured the young student's passion for theology, and he never became a priest. But he instead became a lower church official known as an abbé, which is kind of like, I think, the French equivalent of an abbot from Britain. Delicai, after his studies, he made contact with Jacques Cassini, the son of Giovanni Cassini, who we all know from the Cassini space probe that it was named after. And Jacques Cassini was very impressed with Delicai's mathematics and methodology, and offered a roof over his head and a salary from 1736 to 1740. During that time, Delicai became friends with Cassini's second son, César Francois, and Jean-Dominique Maraldi. The Maraldis and Cassinis, they all kind of grew up in the same Italian town, so they're very closely knit families during that time period. Now there's a conflict going on between Isaac Newton and René Descartes about gravitation. And of course, Isaac Newton, his theory and laws of universal gravitation, as we all know today, and René Descartes, his idea of gravitation was with other vortices. And there were promoters and detractors on each side. In some ways, it became almost patriotic, with a lot of British people supporting Isaac Newton and a lot of French people supporting René Descartes, almost out of patriotism. But Delicai, Voltaire, and Maupertuis, they were promoters of Isaac Newton because they felt that his methodology, his understanding of gravitation was superior to kind of this unsubstantiated other vortices of René Descartes. However, the Cassinis, they did support Descartes' theory, so it kind of led to some exchanges between the two groups. Now, during the mid 1730s, measurements were performed, and those measurements indicated that the Earth was actually a prolate ellipsoid, which was predicted by Newtonian gravitational theory. And there were 2 expeditions that were led. One was headed by Maupertuis, with Le Monnier, Clairaut, and Celsius. And another group went to Peru for 10 years, and they succeeded in measuring the Earth flattened at the poles. Jacques Cassini, who he supported René Descartes, he tried his best to find an error in the measurements because, well, Isaac Newton must be incorrect with his universal gravitation theory. However, Maupertuis gave a raucous account of the journey and basically eliminated all questions as to the shape of the Earth. Even Voltaire told the crowd that Maupertuis had flattened the Earth, and at the same time, he flattened the Cassinis. So universal gravitation was here to stay, and that's the understanding that we have today. Well, I guess prior to, I suppose, general relativity, of course, but universal gravitation is well used today in basic calculations of astronomical physics. So another mission was to measure the Paris Meridian, and this was undertaken by Cassini III, Maraldi, and Lecaille. And the survey provided a measurement for the radius of the Earth. And years later, the Royal Academy of Science wanted to denote a new unit of length, which they said was, let's call it 1/10,000,000th of the distance from the equator to the pole. And that provisional unit was the first meter. And that was to within a few fractions of a millimeter that it is today. The survey used positions at the same latitude but different longitude. Gunpowder was ignited and the sound timed. Lecaille surveyed large triangles between landmarks to calibrate distances. He climbed mountains, lit bonfires, and camped out under the stars with very little to eat. This is going to become a familiar thing with Lecaille. He was extremely dedicated and passionate about his measurements and his lab work out under the stars. In the Pyrenees, his horse was swept away by a raging torrent with Lecaille on it, and they thought he had died. However, a few hours later, he showed up to the camp, he changed, and then he went straight back out to work again right away. And that was his character. He was very, very strongly excited about the work that he's undertaken to contribute towards scientific advancement in the field of astronomy. In 1739, he became a professor of mathematics at the College Mazarin. He established an observatory there in 1742, right above Cardinal Mazarin's tomb. And he was appointed adjunct astronomer of the Royal Academy of Sciences. He was an avid textbook writer, and he took teaching extremely seriously. And he was, although being French, he was highly Newtonian in his teachings. He supported Isaac Newton fully, and taught the theories and laws of Isaac Newton as though they were gospel, which is good because Isaac Newton had kind of had the correct side of what was going on with physics at the time, for sure. He taught about extraterrestrial planets, which was extremely far ahead of its time back in the 1700s. So he had a really good insight into astronomy at the time. But all these missions to survey the Paris Meridian and the shape of the Earth, that pales in comparison to his big mission, and that was observations in the southern hemisphere. not many had been done at the time, or at least known to the Europeans. So, there were kind of four main things that they wanted to do, and that was determine the position of the Cape, which there are measurements that differed by about 450 kilometers or so. Determine the parallax of the moon, to observe the parallax of the sun, and complete a catalog of the principal fixed stars. So he developed a plan and proposal. He obtained support from the Dutch, because, well, that was their land at the time, to the Cape. It was a commercial colony operated by the Dutch East India Company. And, well, unfortunately at the time, France and the Dutch, well, they were kind of recently at war. So, it's a lot of negotiations had to take place. But one of the marquises, the Secretary of State for Foreign Affairs, asked the Netherlands ambassador to ask its government, and Prince Willem IV was approached directly. And this Dutch prince actually is very interested in science, and he told the governor at the Cape to render whatever assistance was needed. So, there are some really good, some gentry who were really excited about science, and helped Lacaille along on his journey. So that's really great. So let's talk about the southern hemisphere. Let's talk about his journey. So started in 1750, and he left Paris to go to the port. And his boat, it was, well, extremely, it wasn't sanitary at all. There were a few living animals for meat. It stunk, it was overcrowded, and the drinking water, it was scarce and it tasted bad. But, there was no clocks at the time, so they had to navigate by dead reckoning. So they kind of moved to they moved their boat to the latitude of Cape Verde, and, well, once they got to that latitude, they just sailed and hoped for the best. They headed west to try to find those islands. But they had some trouble, and unfortunately they ended up in Rio. So they stuck it out in Rio for a month and then set sail again east to find the Cape of Good Hope. And the governor was very happy to welcome Lacaille. The governor had received the Prince Willem IV's letter, and very happy to receive him when he arrived in April of 1751, and he stepped ashore at Table Bay. Now, it's kind of look at Table Mountain there, and just kind of remember that, because we'll talk about that mountain a little bit later in the presentation. So this is kind of his trip. The red line, he went out using dead reckoning, and then just said, oh, let's head south. Oh, we missed Cape Verde, so let's just stop over in Rio, might as well. And then they headed east to the Cape of Good Hope. They did kind of move over to Mauritius a little bit, and then came back, much more tighter course to Africa. But let's talk a little bit about what he did. So, I think it was, so he arrived, what was April 20th, 1751, he arrived. 2 days later, that hardcore work ethic, he planned to make an observatory. A week later, the workmen arrived to build the observatory, and by August it was up and running, and his survey of the southern sky started. And it lasted for, over 11 months. And August the 6th, the very next year, was the first time he slept on a clear night. So every night that was cloudless, that was clear, he'd be up working for the whole year. Can you imagine doing that. Like, you know, if there's a clear night, yeah, I'll go out with my telescope, but every clear night, no, I'd want to rest. But no, Lakai, he was out on every clear night to map the stars. So in 1763, a book was published called Coelum Australe Stellariferum, and that was published in 1763. It had to be finished by Maraldi because Lakai had unfortunately passed away. And it contains Lakai's observations of 9,700 stars, and it talks about nebulous objects that he found that we'll talk about in a bit. And he also commented that the Magellanic Clouds seem to be of the same nature as the Milky Way. Now, this is far before we understood what a galaxy was. So, you know, it's kind of providing some insight into that as he goes along. The Herschels, well, they later surveyed both the north and the south skies and found, you know, that his work was great. You know, not really any errors associated with it, and you know, it's very, very thorough and provided a really good insight into the southern skies. Now, what did he use to do these measurements? Well, he used the zenith sector, and it had a radius of about 2 meters and it was used for finding the latitude from the stars. The telescope was fixed centrally to the frame, and the length of the scale was 51 degrees, allowing it to be swung only up to 22.5 degrees north or south of the zenith. It was built in 1738 for the survey that Lakai undertook with Cassini III. And that's kind of a artistic rendition of the zenith sector that he used for this trip. Lakai's favorite instrument was the quadrant. It was 98 centimeters in radius with slightly lower accuracy, and it was more general in its capabilities. It was used in the sky survey for basically the mass production of star positions. Of course, he used a sextant that was about 2 meters in radius, and this sextant actually still exists in the old Paris Observatory. And it was used for measuring the position of a small number of bright reference stars with high accuracy. It was used to calibrate the less precise but more numerous positions during the sky survey. Scale was 64 degrees, and a telescope of, like I said, 1.9 meters was fixed to the frame at the 0 point of the scale. And he also had a telescope with a 14-foot focal length. He called it the really good one, and it was used to observe the moons of Jupiter. And how he divided up the sky for his survey? Well, he divided the 66.5 degrees between the Tropic of Capricorn and the South Pole into 25 equal zones, just less than 3 degrees wide. The survey telescope was a 71 centimeter focal length and an aperture of 13.5 millimeters. And that is not a typo, actually. It's literally 13.5 millimeters. Imagine an aperture of a telescope that's only just over a centimeter wide. And that's kind of how he did his survey. And I bring up the idea of a reticle because you'll see how that comes into the next part of the talk. He had bad seeing from prevailing southeast winds and used a diamond-shaped reticle and timed the object as it entered and left from that reticle. The right ascension was measured by the average of the 2 times. The quadrant was always set on the meridian, and the telescope was pointed at a fixed angle from the South Pole for a night so that all the stars in the zone had to pass through the eyepiece. 1/3 passed between dusk and dawn. He estimated he needed 100 clear nights for 6 hours. So Lakai's survey took 17 full nights and 110 other sessions of 8 hours each. So, think of a man who spends 7 to 8 hours each night with his eye continuously pressed to a telescope where he observes all the stars that can be seen. Sometimes he'd be standing, sometimes lying down when observing the zenith, always fighting sleep. His original plan was to observe only those stars brighter than magnitude 4, but since they weren't very numerous, his eyes grew heavy with sleep between them. So, you know what, he decided to observe all the fainter ones to be always busy. He was often in an inconvenient position for so long that he had a support made in the shape of a fork on which he laid his head. As well as observing, he had to count the ticks of the clock and write at the same time without interrupting his viewing. The clock face was illuminated by a dim lantern, so faint that it would not affect his adaptation to the dark. To further preserve his sensitivity, he closed his right eye when not looking through the telescope, such as when he was making notes. So, very, very dedicated to his science. And then he went back in 1752, about 2 years after he left. And he did find a dog on his journey and named his dog Gris, which is actually the name of a cape in Mauritius, named after that dog that actually passed away there on his trip. Then, before we get into the constellations and objects, let's just quickly talk about his later life. He had some famous students, Antoine Laurent Lavoisier, and you might know him as the father of stoichiometry. And anybody who's taken high school chemistry has certainly fought with stoichiometry. I know I have. He talked about the conservation of mass in reactions. He was actually the person who named oxygen what it is today. But unfortunately, he didn't make it through the French Revolution. He was guillotined during the French Revolution, which is a big loss to science for sure. Another one of his famous students was Jean-Sylvain Bailly. He edited Lakai's star catalogs. He did original astronomy research for 10 years. He was big into the history of science. He was deputy from Paris to the Estates General. He presided over the tennis court proceedings. And after the fall of the Bastille, he actually became the mayor of Paris. He tried to slow down the revolution and have a settlement with the monarchy. That's just not good. No, yeah. So he was also guillotined during the French Revolution. Nicolas Louis de Lacaille, he died in 1762 of a neglected cold caught in the observatory. That based on his personality, that's something that you would expect from him. And his funeral was held in St. Sulpice, and he was buried in the chapel of the College Mazarin. Some things just to kind of say about him is that 3 months before he died, he was offered a place in the Chateau de Vidken by King Louis XV, but he didn't get the chance to move in. Here's what some people of his time said about him. His student Bailey said his character was that of a lover of truth. He said straight out, bad luck to those who can be wounded by it. And Grandjean de Fauci said, a friend of the truth to the point of imprudence. He dared to speak it to a person's face, even though it might displease, though without any intention of shocking. And also it said, he never solicited any favors nor aimed to make a fortune. It happened so to say that fortune herself came looking for him, but his extreme modesty and the modesty of his desires took the place of opulence and he was perhaps happier in suppressing desires than in setting about satisfying them. He lived as full of virtues as of knowledge, and that he lacked none of the virtues of a perfectly honest man, a dignified cleric, a great astronomer, and an excellent academician. So, you know what, with his life and his survey in the Southern Hemisphere, let's talk in more detail about his contribution to the Southern Hemisphere astronomy, and that's through his constellations. Now, just a reminder, what is a constellation? Well, a constellation, it's not specifically a pattern of stars in the sky. It's kind of like on Earth, we have countries defined by specific borders. In the sky, very similar, we have 88 different countries, which are known as constellations. So the sky is broken up into 88 different regions that are known as constellations. And here's a picture of Lakai's planisphere, which we will go into in detail. So first of all, Lakai sunk the Argo. And what I mean by that is there was a constellation called the Argo Novice, and it was a very, very large constellation. And it was possibly derived from ancient Egyptian as the boat of Osiris, and it became associated with Jason and the Argonauts. Lakai noted that there were more than 160 naked eye stars, which, you know, the point of a constellation is to make it easy to find things. And if you have a constellation with 160 naked eye stars, you know, he thought of the idea, let's break it up into smaller ones. So he broke it up into 3 constituents. And that is what we know as Carina, Vela, and Puppis. Carina representing the hull, Puppis representing the poop deck, and Vela the sails. And John Herschel, 100 years later, fully supported that breakup, because 160 naked eye stars, it's going to be very difficult to really, you know, label things in that region of space. That's just kind of just below Sirius there. Now, Lakai, well, he basically came up with constellations for the Southern Hemisphere. A lot of the constellations in the Southern Hemisphere are ones that Lakai developed during his survey in the early 1750s, and we'll kind of go over those. The first one is Antlia. I'm going to talk about its brightest star, Alpha Antilii, and its declination is from 24 to 40, and it represents an air pump. And the brightest deep sky object is NGC 2997. It's a spiral galaxy. Now, what's another constellation that he came up with? Microscopium. Now, all these constellations are things that he would find in his lab back in France. And that's kind of why the talk's entitled The Southern Hemisphere Laboratory. Microscopium, you know, the famous British astronomer Sir Patrick Moore actually described this constellation as totally unremarkable. The brightest star is magnitude 4.68, and it's likely invisible to anybody living inside of a city. It'd be a good challenge to see if you can pick out any stars from this constellation at a dark site. The declination is it's high enough that you can actually see part of this constellation from where we live in Canada, but you know, the challenge is to find them with them being so dim. It also doesn't contain very many observable deep sky objects at all. But a group of 6 friends in New Zealand actually found a supernova in NGC 6925 in 2011. 6925 is probably the only deep sky object worth hunting for as a backyard astronomer, although it has a magnitude at a faint 11.3. And with a declination of 32 degrees south, you'll be fishing close to the horizon for that one, which, you know, can certainly be tough on a good night. And the brightest DSO 6925 right there. Sculptor is representing, well, here's a close-up of his planisphere, kind of like kind of the sculptor studio. You know, it was originally named Apparatus Sculptoris, which in Latin means the sculptor studio, and it represents a carved head on a tripod table with a mallet and 2 chisels next to a block of marble. I'm not sure how you get that from this grouping of stars, but you know, most constellations to me are like that. The constellation has quite a few deep sky objects scattered throughout its relatively sparse stellar collection. The Sculptor Galaxy, also known as the Silver Dollar Galaxy, is a fairly bright object in the northern parts of the constellation. The northern parts are accessible to us here in Canada. And, you know, from here in Calgary at 51 degrees latitude, it's about 15 degrees above the horizon. So, you know, in Hamilton, I believe it's about 7 or 8 degrees more south than Calgary. So, you know, you'll have a fairly high sky to be able to hunt for that object. And there's a picture of the Silver Dollar Galaxy, also known as the Sculptor Galaxy. Moving on to another piece of equipment in his lab, Fornax. It represents a furnace, and it actually seems to be, in my studies, it seems to be more interesting than the other of Lakai's constellations. It has several bright stars and plenty of deep sky objects. It's actually almost completely visible from here in Calgary, and certainly completely visible to you out in Hamilton, because its declination range, it just goes down to 39.5 degrees south. And the Fornax Dwarf Galaxy is located just to the southwest of Beta Fornacus, and it's a satellite galaxy of our own Milky Way, and it's relatively nearby at just under half a million light years. And well, if you want to have fun with astro imaging, try to see if you can find several of its 6 globular clusters. So there's the Fornax Dwarf Galaxy. It's kind of a elliptical galaxy, although it looks almost like an irregular shape to me. Moving on, Pyxis represents the compass box. You know, it represents the nautical compass box found on many ships. Again, this is another one that's fully visible from Calgary and Hamilton. Declination only goes as south as 37 degrees south. Contains quite a few bright naked eye stars, which should make it relatively easy to find in the sky. There are quite a few interesting objects in there for amateur astronomers. There's a planetary nebula, NGC 2818, that lies in the southern reaches of the constellation. And there's another one, NGC 2613. A lot of astrophotographers like to go after that one. It's a spiral galaxy located in the northeastern hinterlands of Pyxis. Yeah, let's take a look. This is the planetary nebula, a picture of the planetary nebula NGC 2818 in that constellation. So very, very, very cool looking nebula for sure. Chylum. This is the chisel. It's continues the theme of the Enlightenment laboratory equipment. Unfortunately, Chylum is only partially visible from Calgary and probably Hamilton as well. It does go fairly south. It's the 8th smallest constellation in area, and it's in quite a sparse region of space and only has 2 stars brighter than magnitude 5. The brightest deep sky object is faint spiral galaxy denoted as NGC 1679. Something that's kind of interesting, well, at least I find it interesting, that Chilum, even though it's one of the smallest constellations, it hosts NGC 1701. And, it's a nondescript galaxy sitting around 30 degrees south. Only reason I mention it is because I'm a Star Trek fan, and NGC 1701 sounds a lot like NCC 1701, which I don't know, maybe some of you might find that cool. Does contain a possible quasar with no host galaxy. So that's kind of the brightest DSO. If astro imagers are having that much trouble getting a good picture of it, it's not too exciting. Horlogium, very, very tall constellation stretching from 40 degrees south to 66 degrees south. It represents a pendulum clock that Lacaille kind of used in his work. It does have quite a number of deep sky objects. They're great targets for amateur astronomers, for those who have access to the sky that low. Caldwell 87, a globular cluster, is there, and that is its brightest object right there. Very beautiful looking globular cluster. Octans. Now, this is kind of an important constellation because it is the constellation of the South Celestial Pole. I've labeled it there. So I've labeled Sigma Octantis, and I've labeled the pole, the South Celestial Pole, right there. So, Sigma Octantis, I guess you can kind of consider that the South Pole, the South Celestial Pole. It's not as close to the pole as Polaris is to the North Celestial Pole. And certainly the northernmost reaches of this constellation is 74.5, so there's absolutely no chance of us seeing this up in Canada. And it represents the octant, which is one of Lacaille's favorite objects. It's not very well known for its deep sky objects. Malot 227 is an open cluster of magnitude 5.3 that sits halfway between Beta Octantis and Phi Octantis. There are a few dim galaxies from the NGC. The odd astrophotographer has nabbed it, but honestly, I don't see a lot of astro imaging work done in this constellation. So not very exciting for imaging, but it's kind of exciting because it's basically the opposite of Ursa Minor in the celestial pole. And yeah, just kind of a boring open cluster sitting in that region. Telescopium, obviously this represents a telescope. We can't see it here in Calgary. You probably can see the northernmost reaches of it in Hamilton. It has an interesting type of star. PV Telescopii is a supergiant extreme helium star. It's almost completely lacking in hydrogen and thus likely formed in mergers and not molecular clouds. It's a variable star ranging from 9.2 to 9.4 magnitude, and you'll need a telescope or a really good pair of binoculars to see it. Messier number 7, the southernmost of the Messier objects, was actually once considered to be Eta Telescopii, but the official boundary set by the IAU in 1930 kind of took that out of Telescopium, and it sits in Scorpius today. There's kind of the globular cluster that makes up the brightest DSO of that cluster. A reticulum is a reticle. This is what Lacaille used during his work. Even though it's a small constellation, Reticulum has several worthwhile galaxies amateur astronomers can hunt for. NGC 1313 is the brightest with an apparent magnitude of 9.0. The galaxy is also known as the topsy-turvy galaxy. there's actually an interesting story about the binary star system Zeta Reticuli. It's a pair of stars that you can see on the right side here. A couple known as Betty and Barney Hill claim to have been abducted by aliens from the Zeta Reticuli system. So yeah, if I'm writing a story about being abducted by aliens, the first place I'm going to think of is they're coming from Zeta Reticuli. No, not at all. I've never, honestly, it's kind of weird. But anyway, a best-selling novel and movie were created around this incident. After reading the story, Zeta Reticuli seems a bit creepy now, but you know, it's actually funny because people have looked for exoplanets in this system, and they haven't detected any exoplanets there, and that makes conspiracy enthusiasts a little upset, and they think that they may be hiding exoplanets there, and scientists aren't telling you. Great stuff. The Earth is flat. No, just kidding. So yeah, there's a Brightest DSO NGC 1313. Nice looking spiral galaxy. Pictor is an easel. You know, it's supposed to represent a painter's easel and palette. Has a few interesting deep sky objects. There's a star known as Captain's Star, has very high proper motion throughout the sky at 18 arc seconds per year. It's only second to Barnard's star. 10,000 years ago, it sat 7 light years from Earth. Now it's almost 13. And it's the closest known star to our solar system that sits in the galactic halo, and may have been a member of Omega Centauri. Of course, the beautiful globular cluster from the southern sky. So you know, these constellations do have some interesting things in there. Now, this is all the constellations that Lacaille came up with while he was there. So Kirkinus, the compass, representing the compass, the technical drawing instrument used throughout the Enlightenment, has some easy deep sky objects, even though it's a fairly small constellation. Has a magnitude 8 open cluster. Caldwell object number 88 is there. It actually hosts an apparent meteor shower that peaks at the beginning of June, the Alpha Kirkinids, which was first and seemingly only noted in New Zealand in 1977. And future studies have indicated they may appear in 2033. Norma is the Carpenter Square. It resides fairly south. It contains the Ant Nebula. I'm sure a lot of you have seen pictures of the Ant Nebula. I use it a lot in presentations because it's a very beautiful looking planetary nebula. Interesting thing about Norma is it contains the fastest spinning magnetar, and an article about possible star quakes from this magnetar. There's an article about that, and the star quakes, even though the star is 15,000 light years away, it was actually felt by our own atmosphere. So, you know, kind of the interesting fact coming out of Norma. And I believe this is our last one, Mensa. Now, this represents Table Mountain from the Cape, the only one that's not named after laboratory equipment. And it represents Table Mountain, which overlooks Cape Town. What's interesting, kind of above the mountain, this is kind of the shape, it's kind of on its side, but above the mountain is the Large Magellanic Cloud. And that's kind of, you know, I found this picture of Table Mountain with a cloud above it. And that's kind of what Lacaille saw. He saw the Magellanic Cloud sitting above this mountain, this representation of Table Mountain. And that's kind of like how you'd see it in the Cape. You know, very, very cool. And yeah, just Brightest DSO is the Large Magellanic Cloud, the satellite galaxy to our own Milky Way. And Lacaille also came up with objects similar to Messier. Actually, some Messier objects were discovered by Lacaille. So his class 1 was a nebula with no visible stars, such as at the time, of course, not using a fancy telescope. Messier 22 is there, Messier 55, Messier 4, a bunch of Caldwell objects. They were called Lacaille class 1 objects, and just kind of showing the Tarantula Nebula located in the Large Magellanic Cloud. I believe it's one of the biggest and most impressive star-forming regions kind of in our area of the universe. Messier 83 was a Lacaille object, a class 1. Messier number 4, that's one that I've actually observed for the Messier. For the Messiers, you can find that in Scorpius. I think it's just to the left of Antares. A Lacaille class 2 objects, nebulous stars and clusters. There's a few Caldwell objects in there. Messier 7, the one that I believe was part of Telescopium. The southernmost Messier object, Messier number 7, open cluster kind of south in Scorpius there. It's kind of, this is known as the Southern Pleiades. You kind of have some nebulous stars that are fairly bright. Messier 7, of course. I find Messier 7 difficult to find from Calgary. It's very, very low in the, actually, when I observed it, I was looking through trees on the horizon, so it was difficult to see. Then finally, Lacaille class 3 objects, stars with nebulosity. There's, of course, a bunch of Caldwell objects. You notice that they're very high numbered Caldwell objects. Unlike the Messier system, the Caldwell system, it's labeled by declination. So Caldwell number 1 is the northernmost Caldwell object. Caldwell number 110 is the southernmost. So that's why you're seeing a lot of very high numbered ones, because they're very south in the sky. But there's also some Messier objects in there. Messier number 6 was a Lacaille class 3 object. And there's Messier number 6 right there, very close to Messier number 7. So what I proposed to do for the Calgary Center was come up with a Lacaille challenge, and I want to kind of maybe put a certificate or something together for that. And you have to find basically all the Lacaille objects above 35 degrees south. So here in Calgary, we're at 51. You can see, if you're lucky, maybe down to, of course, like 39 or so degrees south if you have like a perfect one. So I kind of shaved off about 4 or 5 on the declination. All the Lacaille constellations above 35 degrees south, you have to find a star in that. All the bright DSOs above 35 degrees south. And then on the moon, find the Lacaille crater, the Cassini crater, the Maraldi crater, and the Lavoisier crater, and the Bailey crater. So, and the Bailey crater is actually a libration challenge. You can only do it certain times of the moon's libration cycle. But if you want to do this for Hamilton, I can make it a little bit tougher by saying, hey, let's switch the 35 degrees south to 40 degrees south. So you can get a few extra objects in there with that extra 5 degrees in declination. There's actually an observing challenge with the Southern African Deep Sky Observing, and where you can actually look for these Lacaille objects, and you find them all and you get a certificate, much like the RASC does with their observing programs. And you can do it with Lacaille objects, which would certainly be fun if I ever head towards the southern hemisphere to do astronomy. So that's kind of my talk on Lacaille. He was a really great scientist, a very good, very dedicated researcher and teacher, very well respected in his field, and he was about 15 to 20 years before Charles Messier. So Thank you so much. If you have any questions, please don't hesitate to ask. I'll do my best, and you can find me on Twitter or through mail based on this information on the screen. So thank you so much.
Well, thank you, Simon. It's amazing to think that somebody had the wherewithal to try to divide the arc of the Earth by 10 million and come up with a meter.
Yeah.
I find that very, very fascinating. Any questions for Simon, folks? Mic up and speak up.
Bernie, I have no questions in the chat at this point in time. And there are no questions from my YouTube viewers that I'm aware of at this point in time.
Oh, well, it was a great biography of an astronomer that we don't hear of very often. The Lakais, I have attempted a few of them myself. I'm very much a challenge acceptor when it comes to viewing objects. I do really enjoy goal-oriented observing and award programs and such, as most of the members in this club know. But I do like the little twist you gave on the Lakai instead of from Calgary for Hamilton. I think I'll take that up.
Bernie,
Yes.
we have a question from Doug. We have a couple of questions actually.
Sure.
So I'll do this one first. This is from Doug Curry. Simon, how much of the Milky Way is there in these constellations?
That's a good question. Like the heart of the Milky Way is in Sagittarius, but I'm not sure how much of all the stars that you see are basically in the Milky Way, but like the actual Milky Trail that you see in the sky, I'm actually not too sure about that. I'd have to look into that.
Okay, thank you. And John Govro, you have a question. Can you turn on your mic, please?
Yeah, hi there. Hi, Simon. It's John. You and I have corresponded via email. It's nice
Hi,
to meet you.
John. Yeah.
Hi. So thanks very much for that. That was really enjoyable. I found it fascinating and learned a lot, actually. So of this selection, the southern constellations are really interesting because the vast majority of them were contributed by a very small number of people. Lakai being one of them. And I'm going to get his name wrong. Begins with a P. He's the one that prior to Lakai, he did about a dozen or so constellations, and they're all the animal and bird ones.
Mm-hmm.
I can't remember his name. Oh, terrible. Right? He did Bruce and Chameleon and all of those, right?
Mm-hmm.
And he was very specific in his theme. They were all animals and birds. And Lakai, with the one exception, right, of Table Mountain, right, was all the instruments from his lab. What do you think was and this is just asking for pure speculation here, but what do you think was going through his head, right, in being so singularly focused, on this theme, when he had not just he had the whole world to draw of experience to draw on, but he was so focused on this one theme for naming these constellations. What do you think is the motivation behind that?
Well, that's a great question, and I would hesitate to guess that, like you say, out of the whole world, his whole world was kind of the lab. Through kind of his biography, he was such a strong empiricist that he spent his life in the lab and out under the stars with his telescope, his octants, and he spent a lot of his time in the lab. That basically was his whole world, and that was probably his greatest source of inspiration. I don't tend to personally draw inspiration from objects in a lab, but hey, if that's like your whole life, then I think that's good for him. And he's very, very, very dedicated individual to mapping the sky, and the equipment that he used, he's basically immortalized that with 12 of the 13 constellations are with lab equipment that he used throughout his life.
Thank you, Simon.
Thanks, Simon.
I have another question from Doug Curry. This is kind of a two-part question. How many of the potentially habitable planets are in these constellations? There is a celestial map with these plotted by Abel Mendez and Planetary Habitability Laboratory, but I can't remember if any of these are in any of the Lacaille constellations.
That's interesting. Yeah, I'm not too sure actually. When I went through the constellations, I was kind of going by kind of deep sky objects and things that I might be able to see here in Calgary. I didn't really look into the exoplanet side of things. All I know is that Zeta Reticuli doesn't have any exoplanets there, so that's about the limit of my knowledge on that subject.
Okay, thanks, Simon. This is the last call for questions. If anyone has a question, they can pop it into the chat. We'll give you a minute or so if I see any pop up.
And while you're doing that, Doug Curry asked a while back how much of the Milky Way is observable in the southern constellations. We totally forgot about the southern Magellanic Clouds.
Mm-hmm. Mm-hmm. Right. Yeah, I know. Yeah, I mean, the Large Magellanic Cloud sits atop Mensa. But yeah, I'm gonna probably go back through this presentation and maybe put in like kind of the heart of the Milky Way in some of these if it does go through there. I'm very much I've never been too much south of 51 degrees latitude, so my knowledge is very northern hemisphere related. So for me, everything kind of stops at Sagittarius, and then my knowledge below that isn't very good.
Okay, I see one
Okay,
more.
Yes, I do. This is from Denise and Chris. Besides Newton, who else influenced Lacaille?
That's a good question. I know people that he fought with on an intellectual level, including Leonhard Euler. Euler wasn't a big fan of his stuff, but through Lacaille's dedication to exact measurements, he was able to prove Leonhard Euler incorrect. So he had influences both positive and, I guess, proving somebody wrong is part of science, and I guess that would be an influence as well, right? You're influenced by if you have detractors, you go out, you prove them wrong, and in that process, the scientific method process, you gain a better understanding that you may not have had originally. So Leonhard Euler was certainly one. The Cassinis, of course, influenced him greatly. And I'd say Galileo, of course, would have influence on him, all those early giants. And of course, sometimes we forget about the shoulders that those giants stood on were a lot of the Muslim scientists throughout the kind of the Muslim golden age, who really worked on astronomy kind of through the dark ages of European history. They kind of bridged the gap between the ancient and the modern, and basically allowed for this Renaissance scientific knowledge of the times of Newton and Galileo to really happen. And you can kind of note that in the sky. There's a lot of Arabic type of names in the constellations. You know, like in Libra, you have like Zubin al-Janubi, and you know, a lot of Satyr and Cygnus. And you know, you have this huge influence on all the scientists of kind of the European Renaissance that really, you know, a lot of the time when I first got into astronomy, I think, yeah, there's, you know, influence from the ancient Egyptians, the ancient Greeks, and then there's kind of this pause up until, say, Kepler, Galileo, Newton, but really there's this huge influx of, you know, astronomers from Persia who really provided huge insights into to set the table for basically the European Renaissance in astronomy.
And thank you, Simon Burney. That's it for questions at this point in time.
Terrific. Well, again, thank you very much, Simon. I will invite you to stick around, enjoy the rest of the meeting if you like. I think we're going to pause for the cause here for about 10 minutes. We'll take a little break. We'll come back at 9:05. Everybody go turn your coffee on, have a chit chat amongst yourselves. We'll be back with the draws. A couple of interesting prizes today.
All right, thank you everybody for your time, and I might stick around for a while if anybody has any additional questions. I'll be hiding in chat somewhere.
There you go. Okay, see you in 10, folks.
Thanks, Simon.
Go ahead and talk amongst yourselves.
Doug, were you going to screen share pictures of the calendar during break?
Beg your pardon?
I was asking Doug if he was going. Nope, he's not there. Okay. Oh, we'll get him later.
People aren't too talkative today. What's the matter? You know, I always wondered how we came up with 39 1/4 inches on a meter. But now I sort of understand.
I guess it beats other different methods of measuring, like rods and even feet, like
Yeah.
an
I
actual
mean,
foot.
Furlongs.
the length of an arm was I thought it was the length of an arm of some king. I thought was a meter or some stupid thing, but this makes much more sense. But then you have to wonder, how did they know where the precise location of the North Pole was and the equator?
You kept going up until you started coming back down again.
You roll it up the hill, and then it rolls down the other side, right?
The scientific version, anyway.
So did everybody get a chance to see Venus in the daytime?
Yes.
That was pretty cool.
Yes.
I wish I had, but we were putting siding on the side of the house at that time, and I didn't have my phone with me or anything, so I didn't even know until it was over. Like, it was dark.
Oh, no.
Yeah.
That's too bad.
Well,
But it would have been
still-
interesting.
It's still viewable in the daytime. It's just tougher to find it.
Yeah, it's further away from the moon. Did you both see it naked eye or just with binoculars?
Yeah. I had to find it with the binoculars first and then move the binoculars away from my eye and keep looking, and I could see it.
Yeah.
It was very bright.
Well, I knew it was super bright. It's actually in my talk tonight a bit about how bright it is, but I thought I might have needed like a cardboard tube to look through to get rid of some of the rest of the sky, the brightness, to be able to see.
I didn't have any trouble, Matthew.
No, very good.
Oh, and actually I dragged Alex out too, and she didn't have any trouble seeing it either. So
Well, she's got young eyeballs.
yeah, exactly.
Janice always picks stuff out of the sky before I do. She'll go, I can see Polaris. It's like, where? Well, I know it's up there, but where? It's right
It's in
there
the
above that
north.
tree. Yeah, it's like above that tree.
Yeah.
It's like I'm looking there. I don't see anything. I try averted vision. I don't see anything. And about 10 minutes later, I'll see it.
Mm-hmm.
It's just my eyes. They don't work like that.
That's like Doug and I, Matthew. He'll see it. He goes, "Oh, there, I see it." I'm going like, "I see nothing. I see nothing. There's nothing there." No, it's right there.
I don't
sure.
believe you.
Yeah, it does happen. And I think maybe it's how your brain works. Maybe some people are better picking out point sources, or maybe it's just our glasses aren't quite up to snuff. We just can't see it, but it's really consistent with Janice and I that she'll see stuff before me.
Yep. Or just the opposite way. I think it's my eyes. My eyes just don't have the.
It's one of the advantages of being colorblind. I can see things that you can't.
Oh.
You're into the infrared then, are you?
No. It's not so much that, but yes, I don't get the infrared, but I don't get green. So it's one of those things where my brain compensates, and what's the one color it shows me just as luminance.
Yeah.
Oh, I see. Yeah. Well, at least you're not missing much in the sky if you're missing green.
Yeah, I've noticed that.
So you're the guy that's always sitting at the green light.
Here's my
Waiting for-
question.
Waiting for a different shade of green.
Here's my question. Should the guy who's proofing the photos for the calendar be telling us he's colorblind?
Oh.
Yes. This way, someone else will take the job.
I'm just teasing you, Doug. Just a joke. Just teasing.
That comment about the street light when we were out west, and I think Simon will appreciate this. The street lights aren't vertical like they are here; they're horizontal, right? And we come up to the first one, and Doug goes, "Which end is green?" And I'm like, "Oh crap! It's on the right. the last one. Yes, that one. Yeah, okay, it's green. Now we can go. Because like he couldn't tell, right? It's like, this is like, oh crap, he can't read the stoplights. Okay.
When we were
So
in
John-
North Carolina, we stopped at, I don't know if it was Charleston or something for the night. I can't quite remember, but every corner that we went to in that city had 2 sets of streetlights beside each other and like right beside each other. And I went through a whole bunch of intersections, assuming that the one that was green was the one for me. And I asked a few people, why have you got like 2 sets of lights right side by side at every intersection? And sometimes multiple sets of 2. And they went, what do you mean we've got 2 lights side by side? Nobody even noticed them. And they live there.
Talking about traffic lights or
Yeah, traffic lights. There'd be two of them side by side. Oh, and sideways. So I had no idea what was going on. And apparently nobody who lives there does either.
some countries like bananas, yellow. Got 2 yellow
John?
spots. You get a yellow before you get a red, and then you get a yellow before the green.
Maybe. I just, if it was green, I went. That was my default move.
You were white. You were in the right color, so down there they would stop.
All right, Bernie, are you ready to get rolling?
Yes, I am. I'm just going to mention to John that I've sent him a little note to the side if he could answer me there. Okay, so we're back and I see Simon's still with us. Yay. Good to hear. Good to see you back. So this month, it's my month or my first time to pick the door prizes. That's a rather challenging thing to have to do. Where's the third one? I've got 3 of them. Where the heck did I put the third one? Oh, there it is. Okay. So we're going to, do we have the family Whitman up and running?
We're here.
Oh, there you are. Blink. You have to blink so I know where you are.
Yay.
We'll start with a book, a beginner's, well, not necessarily a beginner's book, Exploring the Night Sky. Terrence Dickinson. Let me see if I can get this somewhat visible. Oh, that's a terrible picture. Okay, we have that. A very good beginner's book. Lots of nice pictures, a couple of charts. Help you find your way around the sky. A couple of challenges. We also have a book about meteorites, 2nd edition. All the history of meteors and meteorites, all sorts of good stuff, the different types. This would be very good for somebody if they were thinking about starting a collection of meteorites. A lot of good background information for you. And last but not least, a planisphere. Oh boy, I really got to change the lights in here. Beautiful planisphere. And every astronomer should have one of these in their kit, even if you know the sky. Okay, so there we all sit with that 1,000-sided dice you've got over there.
Yeah, we're all good. Got all the
All
names.
up to you.
All right. So our first winner is Michael Jefferson.
Michael. Which Michael?
Michael Jefferson.
Mike Jefferson. All right.
Is he with us?
Oh, he's there,
Yes,
but
yes,
he'd probably forgotten to key his mic.
yeah, yes, he's here.
Okay.
All righty.
Second of all,
Next we have Lorraine.
Lorraine. Where's Lorraine? There she is. Okay.
Which one? There's two.
Yay.
Yeah, okay, yes. There
There's
she
two
is.
Lorraines.
There's 2 Lorraines?
Mhm.
She looks like she
One is-
dropped off.
There's
Yeah,
Lorraine.
one is Lorraine Rogers and one is Lorraine.
No,
And
just
you
Lorraine.
guys,
Oh,
Just Lorraine.
Just Lorraine.
Just Lorraine.
Thank you.
We'll give it to the one that's here.
Yay.
And last but not least,
We have Jim Rose.
Jim, where are you? Light up so that we can find you. Jim Rose.
I see him on the grid. Oh, yeah.
He's down there. Okay, you folks, you can contact me through chair at our club, and we can discuss how you can pick up your prizes.
Here's Jim.
All right. So we're going to go. Thank you, family Whitman.
No problem.
Half of the family Whitman. Where's the other half of the family? Where's
They're hanging
Brian?
out.
Okay.
They're behind the scenes.
They're behind the cameramen,
Yes.
producers and stuff. Okay. All right. So now we're not going to jump right away to Matthew. We're going to take an aside and let John have a couple of minutes, because I'm sure he has some very exciting information for you. Everybody pay attention and get your pencils ready.
Thanks very much, Bernie. I don't need a couple of minutes. I only need a couple of seconds to say that the HAA Beginners Group Astronomy 101 will be back. Look out for an email coming out this weekend, inviting you to sign up and join in. We'll run the same format, scheduling wise at least, as we did last time. We'll take the opportunity between now and the holidays to get everything signed up and get everybody's links sent out to them. And then right after the new year, we'll launch into the program. Last year, we had a tremendous amount of fun. Going online worked really, really well. We had a really fantastic group. And this is for anybody who's interested in learning a little more about introductory amateur astronomy. It's an opportunity to learn about how telescopes work. If you're interested in getting a telescope out of the club's loaner program, this is a great opportunity to do that. Learn about how they work, learn about what to see in the sky with those telescopes and all kinds of other stuff. We've got some new material that we're introducing this year as well, beyond the ones from the past year. And it's a great opportunity to meet your fellow club members and get a chance to know them and be a little more active within the club. So keep an eye out for the first email inviting you to join in. That's coming out within the next couple of days. And I hope to see one and all at the HAA Beginners Group, HAA Astro 101, we like to call it. So good. Thanks very much, Bernie. Appreciate it.
You're very welcome. Thank you, John. Looking forward to doing it again this year. Okay, Steve, now's your opportunity.
All right. So as tradition continues, each year I make a trip down to the RASC headquarters and pick up a carton of these Astronomers Handbooks. Any member can email me to reserve one, and we'll make arrangements to get it to you, or more accurately, for you to pick it up more or less at the same time we do the calendar pickups. The deadline for making up your mind, if you really want one of these things, is going to be Sunday night. So actually, let's say Monday at noon. So you can send me an email. The email I'll put into the chat, and you can pick it up. And there'll be $20. That's the same price as last year. And so far we have 10 takers. So anyone interested, send me an email. Thank you.
Great. Oh, it's always good getting that book. It's always good to see what's happening on your birthday. All right, Matthew.
Yep.
Are you all set and ready to roll?
I am.
Awesome. Take her away.
Okay. Huh? Get rid of that. What is this thing here? Get rid of that.
There we go.
All right, here we go.
There we go.
Yep.
All set.
Already. Okay, so welcome to the sky this month for November of 2021. My opening slide was given to me by Bob Christmas. He took this image on Monday evening after sunset. And it's a really nice image of Venus and the moon, a crescent moon. The Earth shine is visible in the dark part of the moon, the shadowed part. And you'll notice there's 3 little stars here. So I'm going to talk about those in a couple of minutes. It's a nice image. But I'm going to start, first of all, on the day before, because the evening before, the moon was on the other side of Venus over here and much closer. And it made for a beautiful sight. Janice and I went outside and we had a really good look at it. The neighbors came over and asked what I was looking at, and I showed them, and then I showed them Jupiter and Saturn, and the husband says, hey, look at those planets all make a line in the sky. So I had to tell him about the plane of the ecliptic and how all the planets circle the sun on the same plane. And it was kind of just a little educational 2-minute thing that happened, but it was fun, and the sky was just pristine that night. It was beautiful. Next day, during the day, a few people started emailing back and forth that they were looking at Venus in the mid-afternoon in full daylight. And what you'll notice here is the moon was near the bottom of the lid of the teapot right there in Sagittarius. And all you did was go to the moon with your binoculars and then go about 1.5 fields to the right, and you got Venus. And apparently it was really easy. So that was kind of cool. And then some people actually saw it naked eye. Once they knew where to look, they could see it naked eye. Venus is that bright at the moment. We would have seen it, but we didn't know it was happening, and we were putting siding on the house, so that didn't work out for us. Like I said, you'll notice the moon is right beside that star here when Bob would have took his image of that part of the sky. And you can see the moon has moved over to just below this star in the handle of the teapot, Nunki. Nunki is a star that if you have to align your EQ mounts, that's one of the stars that comes up to align your mount. I'd never heard of it before until about 5 years ago when I started doing this type of thing, and Nunki came up and I had to look it up just to see what it was. Anyways, you'll notice the moon has moved from there to there. And what happens is about every hour, the moon moves its own diameter, about 0.5 degree in the sky relative to the background stars. And that's how you can actually see it move even in a few hours relative to where it started. Also, the 3 stars I talked about in that image are Nunki, and then this one here, the base of the lid, and this one here at the tip of the lid. Those are the 3 stars you can see in the image. So again, here's the image without all the words all over it, and the 1, 2, 3 stars. That one's Nunki right there. And during the day, the moon was right down here. So it was kind of interesting. I usually, when I take images at dusk or dawn, I like to figure out what the stars are in the image, only because it gives you some sort of perspective as to what's actually in the sky at that time in that direction. Now, if you missed all this stuff, you can try again in December. On the 6th of December, the moon in the evening sky in the southwest is going to be directly below Venus, only a couple of degrees away. This is going to be really, really nice. It'll be after sunset. You can see here the time is about 5:30 in the afternoon. Make sure you have a look. If you miss it that night, or we have the ubiquitous clouds come across the Great Lakes, try again the next night, and the moon will be up here in Capricorn between Jupiter and Saturn. So you've got a couple of chances right there on consecutive days to try and catch the moon in close with the planets. Bob also sent me this image of M33. This is otherwise known as the Triangulum Galaxy, and it is a galaxy in Triangulum, which is actually 3 stars that make a very, very thin triangle. And he used just a regular SLR camera, digital SLR, with a 300mm telephoto fast lens on it. He had it on an EQ mount with no guiding, so no guide scope. This is just good polar alignment, and let it run on its own for a minute and a half. And He has no trailing in his images, so he did a really great job with a manual mount, getting it absolutely perfectly polar aligned. And you wouldn't be able to go much longer than 1.5 to 2 minutes with a 300mm lens on that mount anyway. So it's a really nice job that he's done. M33 itself is very dim. So some of the people, we've seen it from, for instance, Cherry Springs for the first time. Some people I showed it to them there. And once you find it with your binoculars, you can see it naked eye. But if there's any light pollution, it starts to disappear into the background sort of grayness of the sky really fast. It's gone. What you will notice in your binoculars, though, if you get a look at it, is you can actually see the oval shape even in binoculars. So where is this thing anyways? Kind of nice to know, right? So tomorrow night at 8 o'clock, if you look into the east, roughly, and look way up, you're going to find Perseus there, and Aries, and above that is Triangulum. And Triangulum sits just south or underneath Andromeda. And there's M33, the Triangulum Galaxy. If you want to try and find it, start with Merak in Andromeda, which is a nice bright star. Draw a line down to the pointy bit of the triangle and just run back and forth with your binoculars, and you should find it in your field of view, M33. The other nice thing about Merak is if you find that star and you go up again the same distance, you're going to run into the Andromeda Galaxy and M110. So it's a really good star for using as a guidepost to find two really significant visual galaxies. Now on the 19th, there's going to be a partial lunar eclipse. It's going to be very, very early in the morning on Friday morning. It's a partial eclipse, but it's darn close to a full eclipse. There's 97% of the moon is in the umbra, which is the darkest part of the Earth's shadow, and only 3% doesn't actually get in there. John Govro took this picture about 7 years ago, and if you take the light bit that's on the right side here and make the light bit over here, you get a very good idea of what you'll see that night, with a nice ruddy orange glow and a little sort of bright edge on the one side. So the real eclipse, where the moon is in the umbra, starts at 2:18 a.m. and that's where the shadow starts taking a bite out of the moon. At 4 o'clock, you've got maximum eclipse, and at 5:47, it's all over. So, except for the snoring when you go back to bed. Anyway, so that's the time period. It's not a super rare event, but it's always very visually impressive when you get to see the moon like that in the Earth's shadow. It's well worth either getting up for a few minutes and looking at it at maximum, or watching the whole thing, whatever turns your crank. It's a good chance for some photography too, really basic photography, like just a regular camera on a tripod. You can get some really nice results. So here's what it will look like on the 19th. In the west, the moon will be quite high up. Stellarium doesn't show this as eclipsed, but it is. And just up to the right is the Pleiades, and just up to the left is the Hyades in Taurus. And it's flanked by Orion and Perseus over here. So it's a really nice opportunity for wide field photography, medium field photography, and of course, close-ups of the moon itself. And you can notice I had just showed you a picture of Triangulum, but was actually sideways compared to this, but the sky, of course, is moving this way through the night. And now Triangulum and Andromeda in this image are setting in the west. So there's a comet that is already visible in telescopes. It should be the brightest comet of the year. It's called Leonard A1, and it's going to become really apparent in the sky if it does what it's supposed to do in the next few weeks. So this picture that's beside it here was taken yesterday at magnitude 9, which means that it's a very dim binocular object, but an easy 80mm scope object. But again, you'll need a very dark sky to see it at this point. Now, closest approach is on December 12th, but it's still 35 million kilometers away, so it's not like we have to worry about it too much. It's going to be closest to the sun on January 3rd. And the maximum brightness is really, really variable. There's all kinds of guesses from magnitude 5, which is naked eye, to magnitude 2.6, which is like a medium brightness star. So there's also the opportunity when it gets really close to the sun that there might be some light from the sun might shine on the scattered tail of the comet and actually really boost the brightness for a night or two. So we'll have to wait and see. Don't bother putting it in your Android or your iPhone because it won't be back for 80,000 years. So not much point in put it in there as a reminder. But if you wait into December, it's going to be much brighter, but also much lower in the pre-dawn sky. So you're going to need a good eastern or southeastern horizon. And then around mid-December, it becomes visible at dusk, very low in the west. So I've got some maps here to show you roughly where it is. And this is for tomorrow at tomorrow morning at 3 a.m. So like in about 5.5 hours. If you were to go outside, you'd find the Big Dipper standing on end here with the handle pointed towards the ground. Across from it is Canis Venatici or Venataci, whatever you want to call it. And Corcoroli is the main brightest star of that little 2-star constellation. And right across from it is going to be the comet. And you can see it's above, I've lost my mouse. It's above Coma Berenices here, and it's in a kind of an interesting part of space. And then on the 19th, that's the morning of the eclipse. If you were to turn around and look to the northeast, you'll find up towards the north, you'll find the Big Dipper, and then you'll look and you'll basically draw a line almost through Corcoroli, and you should run into this with your binoculars just off the one of the stars in Coma Berenices. So, you know, while you're looking at the moon, you can turn around and try and spot the comet. Then on the 24th of November, this should be really cool. It should be really interesting. The comet, which by then should be magnitude, I would say 7.5 with a nicer tail, is going to be passing right beside a galaxy called the Whale. And this one down here is called the Hockey Stick. And it's a very, very well-known couple of galaxies that I've seen together in a wide field eyepiece in my 12-inch Daub from really dark skies. And they really do look like this, even in a Daub at, you know, from a dark sky. But now you're going to have the comet passing right through there. So again, this is at 4 o'clock in the morning, but if you're crazy enough, you can give it a go and try and catch a picture of this. It will be really worth it. And then on December 3rd, again, it's going to pass something really interesting. It's going to pass the globular M3, which is a gorgeous globular and one of the nicer ones visually to look at, that, in my opinion. And the comet will be just below it, and the tail will be pointing right back up at M3. So this is another great opportunity. Unfortunately, it's at 4 o'clock in the morning, but by then on December 3rd, the comet's tail should be getting much better, might even be naked eye visible at that point from a dark sky. And then just 3 days later on the 6th, it will have moved down into the constellation Bootes. And you can see here that the comet is midway between Arcturus, which is sort of the anchor star for the whole constellation, and Izar over here. Now, one of the things is if you were to draw a line, just like it shows on here, the comet's going to be just above that line, almost exactly in the middle. And if you've got your telescope out, try some really high power eyepiece and try and split Izar. It's one of the really beautiful doubles in the sky. It requires a steady sky. It's difficult to otherwise to split, but it's gorgeous colors and well worth your time. One of the stars, the smaller one, is actually like a purpley mauve color. It's really pretty. And what else do we have here? Oh yeah, so then around mid-December, as I said, the comet's going to move into the evening sky in the southwest. And you can see here at 5:30, the sun is set. You can start looking for it around the 17th. and it's going to stay in this area of the sky as it moves around from our point of view. And on the 17th, it'll be right below Venus. So even though the comet in that twilight sky will be hard to pick up, you can use Venus as your guidepost and just look straight down with your binoculars and see if you can pick it out. You'll need a really, really good clear horizon to the southwest, because even at this point here at 5:30, it's only 8 degrees above the horizon. So, you know, you've got a very narrow window to look at it, because even as it gets darker, it's going to be setting down this way along with Venus and everything else, of course, as everything sets. So I would encourage you to find a place with a great southwest horizon and see if you can pick it up in the evening sky. And from there, it's only a week till Christmas. So what do you know? And that's it for me. It's a short one this month. But, I thought it might go long with the calendar sales and everything else. So I kept it short, and that's it for me.
Well, thank you very, very much. Always interesting and factual and fun. And there's always a challenge. And I appreciate that, as I'm sure other people do as well.
Hopefully.
I hope so too. You were mentioning that comet's going to be only about 8 degrees below or above the horizon. I was thinking at the same time, on that date, the temperature is probably going to be about 8 degrees as well, but minus
Fahrenheit.
Anyway, anybody have any questions, queries, anything? Comments, statements?
Thank you very much.
You're very, very welcome. Always a
I
pleasure.
seem to have lost the picture of me, but that's okay. I heard everything.
That's okay. We saw you.
Yeah, once is enough.
Oh,
Thanks.
it's never enough to see our members, especially when you can't see our members.
Well, I'm actually enjoying the meetings, and I did come once to the dark sky site. I'm enjoying it in some ways more than I did while I lived in Toronto with the RESC. There's a lot of enthusiasm here. That's great. So thanks a lot. Okay.
You're very welcome. Very welcome. Your
See you
comments
next
are
time.
appreciated.
Thank you very
See you
much.
next time.
Yep. Take care.
Anybody else have something? Oops, sorry, Tom.
Oh, it's okay. Good night.
Good night, Tom. Anybody else? All right. That's it. Our next meeting for the membership is the 10th of December. Between now and then, I expect everybody to go out and buy me a gift certificate for Christmas. And
Now I know you're
come on, I
hallucinating.
gotta try. Be safe, everybody. We'll see you next month.
Good
Good night, everybody.
You too.
Night.
Be safe.
Good night.
Have a good night.
Good night.
Good night. Good night.